Okay, folks, let's continue on with the supplement problems, and let's look at what I call the at most multisets. So in problem 5, how many multisets of size 7 are there taken from the set with x, y, and z in it, with the property that x cannot appear more than once, y cannot appear more than 4 times, and z cannot appear more than 5 times. And I would point out to you that 1 plus 4 plus 5, that's bigger than 7, so we do have some leeway there to construct the set. Now the way that we approach this is using the inclusion-exclusion principle. We need to know how to deal with the entire set of multisets. So U I let be all multisets of size 7 from x, y, and z. And then I'll let A be subset of U with x appearing. And I want to think about the complement of what I have here. So x can appear no more than once. That means either 0 or once. The complement would be that it can appear 2 times, 3 times, 4 times, 5 times, 6 times, or 7 times. But at least 2, right? And then B be the subset of U with Y no more than 4. The complement of that would be at least 5 times. And then C is a subset of U with Z it appears now can appear no more than 5 times. We're thinking the complement of that, so at least 6. Okay? So then we start to calculate these cardinalities. Now, all multisets of size 7 from 3 elements, that's 3 things multi-choose 7. Okay? So that is 7 stars with 3 minus 1 bars. 9 choose 7, which I believe is 36. And then let's worry about all these singles. 3 things to choose from. 7 is the length that I want, but I want with A, I'm going to go ahead and put X in there twice. So that means I've got 5 slots to worry about. 3 multi-choose 5. So this is 5 stars plus the 3 minus 1 bars. And so this is 7 choose 5, which I found to be 21. And then B, all right, we got the 3 items, or 3 things, X, Y, and Z, length 7, but this time I want to put at least 5 things in there. So this is 3 multi-choose 2 things, 2 stars plus 3 minus 1, 2 stars, 2 bars, and I want to multi-choose, or I want to find the location of the stars. So this is 4, choose 2, 6. Okay. And then C, 3 things, multi-set of size 7, but I want C to have Z appear at least 6 times. So I just have to fill that one slot up. This is 1 star plus 3 minus 1 bars. Choose 1. So that is 3, choose 1, 3. And we're almost done counting things here. Let's look at some of the intersections. A intersect B. 3 things to multi-choose from. And to be in A and B, I've got to have X appearing at least 2 times, and then B appearing at least 7. So the length is 7 minus 2 minus the 5. This is 3 multi-choose 0. So no stars, and they only need 2 bars. I'm going to pick none of them. 2, 0 is just decided to be I did that completely wrong, sorry. You have 2 things. How many ways can you choose none of them? 1 way. Don't choose it. Okay? And then I believe the rest are 0. So let me start putting a few up here. A intersects C. If you'll notice, you've got 3 things to multi-choose from, but you're going to put 8 items in there. It's length 7 minus 8. Since this number is negative, you can't have a list like that. Same thing happens with B intersects C. Three things to choose from, multi-choose from, but then 7 minus 5 minus 6 isn't going to amount to anything. And let's see, AB, AC, BC, and then lastly it's A intersect B intersect C. So then I got 7 things, but I got to put 11, 13 things in there. 2 minus 5 minus 6 just gives me 0. So the way to calculate the number of things in A complement intersect B complement intersect C complement is to take all things in the universal set, which I did earlier. Minus all the singles. Minus all the singles. I said it. Now just do it. Plus all the intersections. Okay. And then minus the intersection of all. Oops, B. Okay. So this is the 36 minus 21 minus 6 minus 3, and then plus 1 and plus 0 minus 0. So this works out to be, according to my calculations, 7. Okay, and I actually took time in class, had a little bit more room to actually show you what they were. You can write them out. Problem 6 says, okay, how many multi-sets of size 20 are there, taken from the set A sub 1, A sub 2, A sub 3, where A sub 1 appears at most 5 times, A sub 2 appears at most 5 times, and A sub 3 can appear any number of times. So really there's no restriction on A sub 3 at all. We'll let U be the set of multi-sets of size 20 from A1, A sub 2, A sub 3. And then A will be the complement of this situation where we have this is a subset of U where A1 appears at least, oops, not 16, 6 times. Sorry. Okay, sorry for that delay. Let's get back to what we're doing here. And then, so we use the multiset size 20. From that set, A is a subset of U where A sub 1 appears at least 6 times. That's going to be the complement of at most 5 times. And then B we can let be the subset of U where A2, A sub 2 appears at least 6 times. That's the complement of appearing at most 5 times. And then A3 has no restrictions, so there's really no need to handle that with a set at all. I mean, at most 20, I guess, so the complement would be at least 21, but that's never going to happen. We only have 20 in the set. So if you do that, you throw in another set there, it's always going to be a 0 count whenever you include that set, so just leave it out. So we do the cardinalities of these things. Cardinality of U, we're doing a multiset with 3 different types of items of length 20, so 3 multi-choose 20. Oh, I was going to say I've got the. Let's say that doesn't look like the right answer. No, I got the wrong problem in front of me. Sorry. 3 multi-choose 20. So that's 20 stars and 3 minus 1 bars. Okay. And then we'll choose the location of the 20 stars. So this is 22 choose 20, which according to my calculator is 231. And then the cardinality of the set A, 3, sorry. Okay, we are going to get through this, I promise you. So with A, we've got the 20, but we're going to place 6 in there. So really we're only concerned about multi-choosing 14. So that is 14 stars and 3 minus 1 bars, and then we'll locate the 14 stars. So this is 16 choose 14, which my calculator tells me is 120. And we're going to have the same calculations for B, so that's also the cardinality of B. The one remaining thing we need to do is look at the cardinality of A intersect B. So this is 3 things that we'll multi-choose from. I've got 20, but I'm going to put 6 of A1 in there and 6 of A2 in there. So minus 6 minus 6. So this is 3 multi-choose 8. So that's 8 stars plus 3 minus 1 bars, and then we will collect positions for the 8 stars. So this is 10 choose 8. That's 45, I think, right? Yeah. So then, looking at the cardinality of A complement intersect B complement, this is the cardinality of U minus the cardinalities of the singles plus the cardinality of the doubles. Okay, so that is 231 minus 120 minus 120 plus 45, which I have as 36. Okay. All right, problem 7 says, how many multisets of size 10 are they're taken from the set ABC, where A appears no more than 3 times, B appears no more than 2 times, and C appears no more than 4 times. Well, you can do all this arithmetic and you'll get the answer, but you may notice I didn't leave much room here because 3 plus 2 plus 4 is 9. And that's less than 10. So there's no way I can build a multiset of size 10 with those restrictions. So 0 multisets would be the correct answer. And you'll get that, if you do all that arithmetic, you'll get that answer. But it's probably not the way you want to go. Okay. Alright, problem 8 says, how many multisets of size 16 are there taken from the set 1, 2, 3, and 4, where 1 appears at most 2 times, 2 appears at most 10 times, 3 appears at most 6 times, and 4 appears at most 3 times. So we got a little work on this one. This one's going to get a little touchy. And certainly when you add those things up, you get something bigger than 16, so we can definitely do it. So let's let U be the set of multisets of size 16 from 4 elements. And then A, we'll let that go with 1. Subset of U with, now remember, we're going to be thinking about the complement to get at most, so the complement of at least 3. Ones. Let's let B be the subset of U with at least 11 twos, because at most 10 times the complement is at least 11. C, subset of U with at least 7 threes. And then D, subset of U with at least 4 appears at most 3 times, so at least 4 fours. Okay? So we got a little calculating we have to do here. Cardinality of U, we've got 4 things to multi-choose from to get something of length 16, so this is 16 stars, 4 minus 1 bars, and we'll choose locations for those 16 stars, so this is 19 choose 16, which according to my calculation is 969. A, cardinality of A, 4 things to multi-choose from, and 16 is the size, but I want to put in at least 3 ones. So this is 4 multi-choose 13. That means 13 stars and 4 minus 1 bars, and then we're choosing locations for the 13 stars. So 16 choose 13, according to my calculations, is 560. Okay. I guess I'll just go ahead and use this down the page. 4 things to multi-choose from. 16 is the size of our list. With B, though, I want to put in at least 11 twos. So I'm left then to multi-choose the rest from 5. The rest of my list will be of size 5. So 5 stars plus 4 minus 1 bars. We'll locate the 5 stars. This is 8. Choose 5, which is, according to my calculations, 56. 4, 16 minus. With this one, I'm going to put in at least 7 threes. So I will worry about multi-choosing then the other 9 positions. So this is 9 stars plus 4 minus 1 bars, and we will choose positions for the 9 stars. This is 12, choose 9, which according to my calculations is 220. Then D is 4 things to multi-choose from. 16 is the length of our list. I got to put in at least 4 fours with D. So 4 multi-choose 12. That is 12 stars plus 4 minus 1 bars, and then choose positions for the 12 stars. I'm sorry, I'm getting a little crooked here. So 15 choose 12, and according to my calculations, that is 455. Okay. Now we need to look at the double intersections. Let's see if I can put a few of these over here. A intersect B, cardinality. I've got 4 items to choose from. 16 is the list, but to do both, I've got to get 3 1s and 11 2s in there. So minus 3, minus 11. So this is 4 multi-choose. I've only got 2 spots left. And so this is 2 stars and 4 minus 1 bars, and then choose locations for the 2 stars. So this is 5, choose 2, which is 10. A intersects C. Alright, again 4, 16 is my list, length. But A and C, I've got to get 3 1s and 7 3s. So I'm left here to choose 6 positions. I'm sorry, not positions, but 6 things in my multi-set from the 4. So this is 6 stars and 4 minus 1 bars, and we're going to choose locations for the 6 stars. So 9 choose 6, according to my calculations, is 84. A intersect D, okay, is 4 things to multi-choose from. 16 is the length of the list. I've got to get 3 1s, and I got to get 4 4s. So this is 4, and then multi-choose 9. So 9 stars and 4 minus 1 bars, and then we'll locate the 9 stars. So this is 12, choose 9, which I did previously. This is 220. Okay. B intersect C. 4, 16, and now B and C, I've got to get 11 2s in there and 7 3s, but that's longer than my list, right? So I get a negative number down there. That's just going to be 0. B intersect D. 4, 16 is my list, but I got to get 11 2s in there and 4 4s. So this is 4, and that's 1, which is just going to be 4 choose 1 when you got 1 star and 3 bars. So 4 choose 1 is 4. Can you still see that? Good. And then C and D, this is 4, 16 minus 7 and 4. So 4, and I'm left with 5 as the length of my new multiset. So this is 5 stars plus 4 minus 1 bars, and we'll find positions for the 5 stars. So this is 8, choose 5, and I've done that before too. That's 56. Okay. All the triples are 0. I mean, if you start to combine things, except for 1. B's the troublemaker because it's so big, but I can do this triple, A intersect C intersect D. That's 4 and then 16 minus 3 1s and 7 3s and 4 4s. So that leaves me with 2 things to multi-choose. And I'm thinking, did I do that one? 4 2. I'm just thinking that seemed like a familiar number to me, but maybe not. No, there it is, 4 2, which is 10. Okay. And so, if we want to wrap this up, and I'll do it without putting all the letters in. This would be U minus all the singles, so minus the 560, minus the 56, minus the 220, minus the 455, and then plus the doubles, 10 plus 84 plus 220 plus 4 plus 56, and then minus the oh yeah, I didn't talk about the quadruples, but anytime you throw the B in, you pretty much messed it up. So the quadruples are 0. Yep, so doubles we're adding doot 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 doot. Okay, just make sure I got all of them. Okay, and then minus the triples, and then the quadruples are all 0 too. I forgot to write that down, but they are. So some nice cancellations there actually. When I do all this, I get this to be 42. Okay. And then 9, let's see, I think I've got just enough time to do this one before I have to go. Multi-sets of size 22. Matthew worked this one and did a nice job of just saying, because we've got some at least and at most situations. He went ahead and put those in, the 5 and the 3, and reduced this down from a size 22 multiset to a size 14 multiset. You can do that, but it causes you to have to restate these at most numbers. You subtract the 3, subtract the 5, and so forth. What I'd like to do is show you how to work this problem without changing the actual numbers. So I'm going to do this slightly differently than Matthew did, but we'll get the same answers, and it's morally equivalent to what I'm doing to what he did. So you would be the multi-sets of size 22 with at least 5 1s and at least 3 2s. Now what I'm doing is I'm keeping my numbers, okay, and I'm counting multisets of size 22 instead of reducing it down to a problem of size 14. So you might think, well, the number's a little larger. Maybe so, but you don't have to rewrite the problem. And what you would need to do, the way he did, is say, go ahead and put your 5 ones and your 3 2s in there, and then just turn it into a size 14 problem. I think when I'm done, I can show you that it's exactly the same issue here. So A then would be a subset of U with, and we're going to deal with 1 here, so at least 11 ones. Okay. You know, I am actually going to have to pause this again. I'm sorry, this has been a kind of a hectic taping, but we'll eventually get there, I promise. Okay, hopefully that was the last distraction. Sorry. So, A, I'm still going to count as a, I'm looking at the at most part and saying a subset of U with at least 11 ones. Now, the very least it'd have 5, but to be an A, it'd have to have at least 11. Okay. And then B, it'd be a subset of U with at least 21 2s, and C be a subset of U with, if it's at most 5 times, then at least 6 3s. Okay? So, counting the number of things in our universal set. I've got 3 things to multi-choose from. It's going to be a multi-set of length 22, but I got to have at least 5 1s and 3 2s. So it's just like I was doing the problem Matthew did, where I have to choose from something of length 14. Okay, I'm just showing you this way because I didn't have to go through and change the numbers. So this is 3 multi-choose 14, which is 14 stars and 3 minus 1 bars, and then we find positions for the 14 stars. So this is 16 choose 14, which by my sources is 120. A, now 3 things to multi-choose from, but I've got to get 11 ones in there, okay, and I still have to get the 3 to be in this. I still have to be get the 3 2s. So this is, and that's 14, so that's 8. So 3 multi-choose 8. That's 8 stars and 3 minus 1 bars, and then we'll locate positions for the 8 stars. So 10 choose 8, and that is 45. And then B, 3, 22, and then I've got to get at least 5 1s in there. But when it comes to 2s, I want to get 21 of those. And you can see that that's going to give me a negative number down there, so that's a 0. And then C, maybe I can put C right here and conserve. Oh, that's fine. I'm worried about space, but we'll handle it. 3, I got 22 things. And I got to get 5 and 3 out of there. So again, that's where the 14 comes from. And then I've got to get 6 3s out of there. So 3, and then this is 11, 14, 8. Is that right? Yep. which we already calculated that number. Right, that's 45. All right. Now let's do some doubles. A and B. 3 things to multi-choose from, and I need to get 11 ones. Okay. And 21 twos. Well, that's too big. That's 32 things, so that's a 0. And then A and C. 3 things to multi-choose from. I have to get 11 ones and now 6 threes. Oh, and I forgot. I've got to get my 3 twos as well. So that should really go there, just to keep it in order 3. And then minus the, oh, darn it, 6 twos. Okay, so that is 3, and then that's 8, 19, 3, I believe. Did I do my arithmetic wrong? 9, yeah, I did. I did do my arithmetic wrong. 9, 20, right, so 2. So that is 2 stars and 3 minus 1 bars. Choose 2, which is 4, choose 2, which is 6. Okay. And I think that's the last thing. I think everything else from that point on is 0. B intersects C. Okay, 3 things to multi-choose from. 22 is the length, but I've got to get 5 ones and then 21 twos and 6 threes, so that's just too big. That's a 0. Okay, and certainly the same thing happens if I try to get all 3. Okay, it's just too big. So the cardinality of A complement intersect B complement intersect C complement is, you think of this as the cardinality of the complement of the quantity union of all 3 of those, which is cardinality of U minus the singles plus the double intersections and then minus the triple intersection. So 120 minus 45 minus 0 minus 45 plus 0 plus 6 plus 0 minus 0. And I get that to be 36. Okay, and that's the last answer. Notice that in all cases we're always subtracting at least a 5 and a 3, so it does resort down to really picking a multi-list for 14 minus some additional stuff. It's just this way you don't have to change the numbers. Okay, even things that once you get down to 14, 24, well 21 minus 3 is, let's see, 17, so that'd be 18. That's still too big, so anything that involves B is just zeroed out, and that's exactly what happens, right? Yep. So it's morally equivalent. Okay, there's the homework for the supplement, and I will see you in class on Thursday for our test. Good luck with that. Let me know if you